So this is the slide of bell work, and I understand that we don't actually have class. You don't technically need to do this slide. However, do actually think about these questions. What is the purpose of the periodic table? We've seen them before, but what is it actually used for? Do you know? And how is it actually organized? Do we just throw a bunch of things into a group and say this is the periodic table, or is there some kind of semblance of order to it? So we're going to be talking about the introduction to the periodic table. Now, these are some keywords that we're going to be discussing. We're going to be talking about the atomic number, symbol, atomic weight, element, compound, and mixture. What are those things and how are they related? This is Dmitry Mendeleev. Now, in his picture, he looks pretty crazy, and he was pretty crazy, but he was also a genius. He pioneered this idea that the elements could be arranged in a list based on similar weights and properties. Now, this has been done before, so why is he so famous? Well, he was able to make a list that had gaps in it. These gaps were elements that have not even been discovered yet. He told people that, look, here's an element that you have not discovered yet, and on top of that, I'll be able to tell you every single thing about the element. This is the origins of the periodic table of elements. His table looked nothing like the table that we have today, but it was the start. We have already talked about this question a little bit before. What is the periodic table of elements? The periodic table organizes all the elements that we currently know about into a table of similar properties. There are still gaps in the periodic table. You will find them near the bottom, and scientists are working diligently to fill those gaps. They're trying to synthesize them in a lab or even possibly find them in the universe. But that is what the periodic table does. How do we read a tile on the periodic table? Well, if we look at it, we have 4 bits of information that we can glean from. The top is the atomic number. This is the order that the elements are actually on the table. Afterwards, we have the symbol, which is what we usually see in chemical formulas. The name is the way that we pronounce it, and then we have the atomic weight. Each one of these things we'll actually get into and talk a little bit more in depth in the next few slides. What is the atomic number? Now, the atomic number, as we already talked about, is how it's ordered on the periodic table, but more importantly, the number of protons that we find in the nucleus. That is what the atomic number is. It is not the number of electrons surrounding a nucleus. However, that number always correlates to the amount of protons that we find in the nucleus anyways. So those two numbers are the same. However, the atomic number is the amount of protons that we find in the nucleus of an atom. What is the symbol? So the symbol is just an abbreviation of that element's name, but we cannot always rely on this because it's an abbreviation of the original name of that element. For instance, lead has a symbol of Pb. Where does that come from? Well, it comes from the original Latin of plumbum. And then Fe is iron. That comes from ferrum. So we can't really say that it's an abbreviation of the element name that we would call it. However, it is an abbreviation of the original name that it had. What is the atomic weight? Atomic meaning atom and weight meaning weight, so it is the weight of the atom. Now, scientists are able to find this by taking the number of protons and adding it to the number of neutrons in a nucleus. Now, you might say, wait a second, this says that carbon is 12.01. How can I get a whole number plus another whole number and get some kind of weird decimal like this? Well, that comes because there can be more or less neutrons in an atom. That number actually varies. So what scientists do is that they'll take a bunch of different atoms, find the atomic number for each one of these things, and average them all out. Now, carbon comes down to 12.01, which means the average number of protons and neutrons in a nucleus is 12. How do we find the number of protons, electrons, and neutrons in an element using this periodic table of elements? Now, you should be able to find this pretty easily. Number of protons is just going to be the atomic number. The number of electrons is going to be the same as the number of protons. The number of neutrons, you're going to take the atomic weight we talked about, minus it from the atomic number, and then round it. We can work with an example for this. If you look at your periodic table, there is Sn, or 50. It's 50 on the periodic table. It's tin. We've all heard of tin foil. So the number of protons is going to be 50. The number of electrons is also going to be 50. To find the number of neutrons, however, we would take 118.7, subtract the number of protons, which is 50, and we should come out with 68.7. We're going to round that to 69 and say that there are about 69 neutrons in an atom. Okay, yeah. Yeah, let's just move on. Here we are going to talk about elements, compounds, and mixtures. How are they different? How are they the same? And how they can be used. What is an element? An element is a substance that is only made up of one type of atom. It has no other types of atoms in it. So as you can see, this first picture of these red dot atoms only have red dots in there. This next picture over here, where it has the yellow dot atoms, I'm not exactly sure what yellow dot atoms are. Maybe there's some type of gas, but they are bonded to each other. You might think this makes it where it's not an element anymore. But as long as those atoms are the exact same, it is still considered an element. Compounds are things that are made up of multiple types of atoms that are chemically bonded together. If you ever see a picture and you see some kind of representation of atoms, for instance, you have the blue and the red dots here, you can see the little line that's between them. That is a symbol for a chemical bond. So this is saying that the two red atoms and the one blue atom are chemically bonded together. Since there are two types of atoms in this molecule, we would call this a compound. Now, what is a mixture? Mixtures are also made up of multiple types of atoms, however, they're not chemically bonded together. You might get this if you make a cup of coffee, or some tea, or drink any type of soda. It's a bunch of different compounds that are mixed together, but they're not chemically bonding to each other. So it's just they're mixed together. We have a periodic table of elements, and I want you to take a look at it while we talk about this. We're going to have horizontal rows, meaning going left to right, and we're going to have vertical columns. These have special names. Horizontal rows are called periods. So if I'm ever talking about a period, I'm talking about a horizontal row of elements. If I'm ever talking about a family, I'm talking about a vertical row of elements.